right, so in the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So we're basically going to prove that FG, right, is congruent to JH if and only if this perpendicular distance between the center and that chord is congruent to that distance between that perpendicular distance from the center here to this chord JH. So let's go ahead and prove this. So proof, since this is an if and only if statement, we're going to do P implies Q. So we're going to assume FG is congruent to JH. Okay. Also, I'm going to draw these radii, right? So, and that'll work for both proofs. So draw a radii, FL, GL, JL, and HL, right? So I'm drawing those radii to help us with this. And we have that perpendicular distance. So let's see. Here, I know these are congruent. FL is congruent to GL, which is congruent to JL, which is congruent to HL, because we know they're all radii, right? So let me do that, and I know this is congruent to this. So right off the bat, I know triangle FLG is congruent to triangle JLH, right? So by side, side, side. So I have FG is congruent to JH. I have FL is congruent to JL, right? And lastly, I have GL is congruent to HL. So these three things together, by side, 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 implies triangle FLG is congruent to triangle JLH. JLH. All right. So now that these two triangles are congruent, I know their areas are the same, right? So that means the area of triangle FLG must be equal to the area of triangle JLH. So that's how we're going to get to prove that these heights of these triangles are the same, right? Okay, or that perpendicular distance between the center and those chords, right? But they also act as heights for these triangles. So we have the area is 1/2 the base, which is FG. So 1/2 FG, oh, let me fix that, FG times the height, which of course is that LX, is equal to 1/2 JH times LY. Okay, so I know, right, that FG is congruent to JH. So this is the same thing as 1/2 FG times LX is equal to 1/2. Instead of writing JH, I can write FG times LY. I can divide both sides by 1/2 FG to get LX is equal to LY, or, right, LX is congruent to LY, which showcases that the distance between L and X is the same as the distance between L and Y, right, which is what we wanted to show. Now let's go ahead and move on to the other way. We're doing now Q implies P. So we're going to assume in this case that LX is congruent to LY. Okay, so now I'm going to be looking at this triangle here, LXG and LYH, right? So I know these are congruent And I know LG is congruent to LH because they're radii, right? I said that in the beginning. So I know, I'll go ahead and write that again. FL is congruent to GL, which is congruent to JL, which is congruent to HL, okay? Because they're all radii. So I know this is congruent to this by assumption. And I know this is congruent to this because they're radii. Okay, so I have, let me scoot down a little bit. So I have LX, or I guess hypotenuse leg. I'll go ahead and do hypotenuse leg. So I'll do the hypotenuse first. LG, or GL, is congruent to HL. I have this leg, LX, congruent to LY. And just to showcase that these two triangles are right, so I can use hypotenuse leg, I have the measure of angle LXG is equal to 90, which is equal to the measure of angle LYH. So by hypotenuse leg, this implies that triangle LXG is congruent to triangle LYH. All right, so now, since those are congruent, right, this means that XG is congruent to YH. All right, so as you can see, I can use the same argument to show this is congruent to this, and showcasing that triangle LXF is congruent to triangle LYJ, right? So similarly, by hypotenuse leg, triangle FXL or LXF is congruent to triangle LYJ. And of course, if those two triangles are congruent, that means FX is congruent to JY. All right, so remember, the whole objective is to assume LX is congruent to LY, implies FG is congruent to JH. Well, I mean, we basically have that, right? Let's see, FG, I know, is equal to FX plus XG, right? FX plus XG. Well, I know FX is the same as JY, and I know XG is the same as YH. And JY plus YH is JH, which of course implies FG is congruent to JH, which is what we set out to do, right? We wanted to show, of course, first, that assuming FG is congruent to JH implies LX is congruent to LY, and then assuming LX is congruent to LY implies FG is congruent to JH.